So before we start, I would like to give just a brief introduction about myself. I am an Avenue coder for over 3 years, been working on a retail client, and for all of these years, I have been creating this passion, developing this passion with software architecting, and this motivated me to achieve a few certifications so far in the cloud world with Google Cloud Platform and AWS. And this also motivated me to start and finish a postgraduate course in software and solution architect. So I have been working with event-driven architecture in my client for over a few years, and a lot of places there that we can improve, and also some other things that we have learned throughout this time. And I'll also be trying to share this with you. So for this presentation specifically, we'll be speaking about a few points of event-driven architecture. We'll have a brief introduction to understand better what means being event-driven. We also see some key aspects of this architecture, some components, design patterns that it has, points of attention when deciding to use and follow these methods or not, when you should not be using it. And also at the end of this presentation, we'll have a very hands-on session, which I believe is going to be really cool. So I tried to bring a few good examples here so everyone can understand it, how it can behave, and how it can be incorporated for common problems that we have. All right. Okay, so let's start with a very provocative question. What means being event-driven? So event-driven is a different approach of what we are used to do. Nowadays, actually, very commonly, we always think of our systems and solutions in the state that what they are. So very commonly, we have this procedural way of thinking. We define steps for things to do. We define paths that need to follow, the logic that needs to follow in a very strict manner to have and achieve an objective. And event-driven has this kind of different paradigm where you deals, yeah, it's where you said how you can create, intercept, and react to the changes that happens around you. Instead of defining what the things are, you actually think of what happens and how this affects your systems and your solution. So these are different parts of how your systems react to changes in the state of your solutions. And the main goal to think this way is how it is to achieve a flexibility and reactivity in your solutions by promoting the loose coupling. So not having things tied too much to each other, and you can have individualized work, parallel work, so you can move faster and have better flexibility when dealing with new strategies. So that's what being event-driven thinking is. So I brought here a very simple example so we can understand a very tangible example. Let's say that we have this person, Lucy. Lucy is a famous writer, a books writer, and she has many fans across the world. Not only these two, there's only two here, but it's because of the slide. So we have Peter and Anna. They are Lucy's fans. And Peter and Anna, they live apart from each other. They don't live together, and they don't know each other. They have never seen Lucy, by the way. They only have read her books. And every time Lucy publishes a new book, every time Lucy creates a new book, Peter and Anna always want to know about it as soon as possible so they can read a new thing, a new book. And they expect all of these books to be received on their email boxes. So Lucy, as a writer as she is, she when she creates the news book, when she finishes a book, she wants to publish it to all her fans so they can receive this copy of the book. And for doing that, instead of reaching directly to them and sending one by one the copies, she actually delegates that work for a post office. So Lucy goes to the post office, and the post office determines the better way of sending these books to each fan mailbox. So event-driven is, this is a very simple example of it, but it's a very powerful manner to see how event-driven is being applied here. So the main benefits of having this solution with the post office in the middle and people waiting for their book from the post office is that first, Lucy doesn't need to know who their friends are, and the opposite is the same. So her fans doesn't need to know where Lucy is. They don't even need to know who Lucy is. They can never see her. And having this part of communication being structured apart, this is great. So each one of them can be individualized and can be independent of each other. So that's great when we are dealing with the coupling. So that's what the coupling is. They are not tied together. They don't need to know anything about each other. And not only that, but Lucy, for example, after she publishes a book, she can work on another book and she doesn't need to know if their fans receive it or not. It's not her part of the work to understand that. So that's great. Now, Lucy's readers, they don't even need to know about these things. They can do their work. And then when they receive a book, they can read the book. And Lucy can work a new book while this first one is still being sent out. So that's great. So they can do asynchronous operations. So like um, software engineers has these terms and they are kind of complicated. Myself, I took like 3 times to write asynchronous correct. But this asynchronous part is how you can do things in the background without blocking your main activities. So while Lucy is writing a new book or I don't know, doing something else, the background process of the books is being sent out to her fans and also the opposite. And the second benefit of having this approach with the post office is that you can have many and many of readers and fans of Lucy's books, and she doesn't have to know about them. We already saw that with this decoupling. But this also means that every time a subscriber doesn't want to receive books anymore, or something happens, for example, and in this case, move it to somewhere else, or doesn't want to receive the books anymore, in this case, we also gain with the scaling and fault tolerance. So as you can see here, we can scale up or scale down the number of consumers, the number of people subscribed to Lucy's books. We can remove one of them without affecting the others. And that's great. So we can have more resilience in the when we're facing abnormal stuff. So, for example, in this case, when Anna stops receiving the messages, when she doesn't receive the books anymore, this problem is isolated to her mailbox, to how their books are delivered to her. All of the others are not affected for that. And that is great when you want to have scaling. So this means that you can scale up to any number of fans. It doesn't matter how many fans, as soon as just assuming that the post office can handle all of them, um, they can scale out to an infinite number of people. So just to give you a summary of what are the benefits of having this approach, this is great not only for software engineer, which we already have got a glimpse of what it means and how powerful is that solution, but also in terms of business gains that we have from that is that first we have agility. We know very quickly what is happening in our environments, and that's great. For example, let's say that Lucy, as soon as Lucy publishes her book to the post office can now quickly send out their books to all of the subscribers at any moment of the time. So they can ship it independently, and they can also have the flexibility of changing their strategy of sending depending on the necessities of the clients. Let's say, for example, that we have, let's say that the post office needs more trucks to handle the delivery of all the books. Let's say that they need to change the routing. So this gives them flexibility so they can shift the strategies depending on what is happening on the environment. And finally, they also have a window of opportunity to innovate in a very quick time. So let's say, for example, that now Lucy's fan, one of the Lucy's fans, is on the other side of the world, so in the other side of the planet, not the world, the planet, and now they cannot deliver these books anymore with trucks, but instead they can deliver that with airplanes, for example. So this gives them the opportunity to innovate quickly and work individually. So yeah, these are the main benefits of having this event-driven approach. It's very scaling and gives you a lot of power in terms of agility, flexibility, and opportunity. All right, now that we understood the key aspects of event-driven architecture, oh, sorry, the fundamental parts, the introduction of it, we are now gonna dive into the key aspects of it. So we are gonna get a bit more technical here, but not much, hopefully. So first, in the event-driven architecture, one of the things that we want to know and understand primarily is to understand what is event. What is an event? So events are basically things that happens and change the state of something at a specific time. So you can look around. A lot of things are happening at the same time. In like every time something is happening, and things are changing. So events are basically that. They can happen. They can happen internally, externally. They can happen in a very minor way. They can happen in a very major way with big changes. But most of all, they cannot be replaced or changed. So they are immutable. They are time. They are tied to time. So we can interpret events as signals emitted by a component when its state changes. So we have an example of that. Let's say that we have a button in your website which has the word subscribe on it. And every time a user clicks on this button, this has a state change. So this means that an event's going to be generated, and this event's going to generate information. And this information can be treated by something else. And on another side of the view, we also have commands and messages. And here is where things start to get a bit tricky. So messages and events are very similar to each other, but messages are more tied to commands. That's why they are both together in the title. Um, and commands and messages are when you want to deal with operations that are not only signaling, but you want to have you want to intend to apply specific actions after something happened. So, for example, we can think of commands as laying down very passive manner, a passive aggressive manner. For example, commands are the type of messages that comes to another component and say, hey, something happened here, an event was signaled, do something, come on, come on. So in this manner, we can understand that commands are tied to specific destinations and fixed recipients. And since they are created by events, they are started by events, um, we can interpret messages as the subset of informations of this event that is being sent to another component, to another part of destination. So in the same example of the button, now that we had the button being clicked and information being generated, now the command and the messages, they are the processing part of what you do with this information that the event generated. So for example, excuse me. So in this example, after an event was generated by this button, a very general, very like generic button click, we could have a command for it. For example, the user needs to be subscribed. So subscribe the user. The user needs to be analyzed. Okay, analyze user based on information that was generated here. So these are the difference between both of them. All right. Another part of the event-driven architecture that we have, which already saw, is the producer. So producers are kind of self-descriptive. They generate events based on specific conditions, triggers, or business logics. It's their responsibility to also not only generate, but also publish it to a central channel of events, usually called as event bus, which is basically a place that all events comes in. We're going to see more about it very soon in 3 slides. And producers, one example of producers is when Peter, for example, bought a Lucy book from a retail store on e-commerce website. And this website, after he finishes his order, the website generate an order placed events to its internal systems. And the counterpart of producers, we have consumers. And consumers, they consume events. They subscribe to this event bus, to the central communication channel, to receive events when they happen. So every time a new event is emitted, is published to the event bus, it's responsibility of the consumer to consume this event and react to it, maybe generating new ones. We don't know. It can happen any other place. So an example of that is that on the same order placed event, when it is emitted, let's say that we want to send a transactional email for that. So this is where the power of the consumer comes in, because now you are consuming an order placed event, and you don't need to know who is publishing it. You don't care about who is publishing it. You just need to care about information that comes from inside this event. So yeah, so in this example, we have this email system consuming this event, and any transactional email could be sent using the order details, for example. All right, moving on to the next topic is the event bus, which is the central channel that we just spoke about. And it is the middle point between publishers and subscribers. It's responsibility of the event bus to broadcast all the event signals that it receives to all subscribers to these events. So let's say, for example, that we have the same marketplace order placed stuff. We have the event bus in the middle, receiving events. You have subscribers attached to it, waiting for new events to be received. So for example, here we have these two, a mail system and the inventory system. And every time a producer creates an event for it, for example, the same order placed event, it is responsibility of the event bus to send the messages to all parts that are subscribed to it. All right. And now let's go to design patterns of that. So now, until now, we saw the major components of it. And the design patterns, they don't switch a lot, but we have more details about it. The first model that I wanted to bring, the easiest one to understand, is the pub-sub model. So publisher subscriber model. And I know that this image doesn't help us a lot. It's a bit more theoretical, but it's a very similar to everything that we just saw now. But now instead of only have one central place and which is the event bus, and this event bus sends to everything to all subscribers, now we can filter out our events by topics. So this is gonna make sense very soon. But basically, you have now subscribers attached to a topic. They wait for an event to come in from a topic. And internally in this communication infrastructure, you deal with this communication, you send them directions to the events um, so they can be sent out to the correct places. So yeah, here it is. The subscribers are subscribed to events via topics, the consumers. So an example of that is a chat room. For example, we have our tools, Slack, GChat, Teams, and all of them have this type of communication with PubSub, which is where we have channels, different channels. And every time someone sends a message to this channel, it is like it's a topic. Everyone that is inside this channel is going to receive this message. Otherwise, they're not going to receive it. All right. And what are the usual use cases for this? Well, the use case for that, the business use case for that, is that this pattern is very good for real-time messaging systems. It is a great way, actually, to include the event-driven architectures. You can add a few policies to these submissions, like topics by groups. You can have personal chats. You can have any type of the systems. Not only that, they are also great for microservices communication. So in a case that you have a distributed architecture and you don't want to use APIs for everything for synchronous communication, you can actually delegate that using this method, excuse me, to communicate asynchronous with the same message without the need of an API. So it's an abstraction of it. We also have the data streaming possibility and machine learning training. This is great because in PubSub, we can filter out messages, we can group them, we can allocate that on specific places depending on their content. So we can imagine, for example, a few solutions using IoT, where they send information, signaling information every milliseconds. And with this pattern, with the PubSub, we can allocate them to specific places, sending out to depending on their content, and use that information to training models or to have a data lake or specific data, big data databases. The advantages of this pattern is, of course, we have a dependency inversion. So as we just spoke for the microservice communication, every communication that we do in API, it comes from the left to the right side. So here we have the service A that needs to know about the service B, needs to know the information that it has, and the service B only has to return the information for service A when it depends on it. So now, instead of in event-driven, when we have this, instead of having these dependencies between these two, now you actually have something in the middle. You have a message in the middle, an event in the middle. And the only thing that you need to know is what is the content of this event. So in the sense, we have the publisher, which is going to send this event, and we have the subscriber that doesn't know the publisher, but knows the content of the event. So now you can see that instead of going to the left to the right, now you have a communication happening on the right to the left. And this is also great for extensibility. So since our customers or our consumers doesn't need to know about who is publishing it, this means they can have many publishers, they can have many consumers, and we are able to scale all of these components horizontally. They can have like million of them. And new components can also be added or removed without impacting the other services. That's great. That's the example that we saw for the messaging for the books. And of course, we also have the asynchronous nature of this pattern, in which we don't have lock on producers, on messages producers, nor in the consumers. The events can be retried at any time. They can be signalized every time to any consumer, and they can just retry this logic with good performance without depending on anything else. But of course, nothing is, the world's not a bed of roses. So we also have challenges with this pattern. The most principal one is the architecture overhead that brings. So usually to handle these complex event systems, you start to have more layers of understanding. You need better strategies for different scenarios. So you start to make your architecture more complex. You have to use new tools to deal with different types of requirements, non-functional requirements that you wouldn't have with a small application, with a simple communication. Not only that, but you also need better strategies for policies. For example, you need better strategies to understand your product itself, so you can have good ways of defining routing policies for the messages, for the events. You also have to deal with the complexity with the events delivery and how the consumers are going to consume it. So it's an overhead that you add when you choose this model. And not only that, but you also need to understand and apply better the idempotency of these events. So you will need to apply a few other cases where every event that happens, every event that is consumed, it is unique and it doesn't change the state of your application if it shouldn't be updating. So let's say, for example, that we have an outage on our system, and now events are duplicated, our consumer is receiving duplicated events. So you would need to have this idempotency, it's a kind of harsh name, with identifiers, so you can deal with them without affecting the state of your application. You can maintain the same state. All right. And the next one that we have, the next pattern that we have is the event sourcing. And this one's kind of a mind blowing, because with this approach, instead of having events being communicated and then just deleted, now they are stored in a persistent event store. So you can imagine the event store like a log of all the events that happens on your system, relevant events. And whenever the state of the business changes, this new event is appended to this event store, to this list of events. So the steps to achieve that is that basically we have an event being generated, it is persisted to this event store, this list of logs, and then system can consume these events because it is acts as a source of truth for everything that happens on your application, for your entities. And the main goal for that is that now you not only are able to reconstruct the system, but you also can pinpoint times where you can change and you can branch something from your state in the past. So yeah, that's a great approach for when you want, for example, um, when you want to have like an auditing system, it's easy for auditing and you have a reliable source of truth for everything in your systems. So we are going to see an example of that. So here we have this modeling where we have a client that communicates with the service A synchronously, and the service A creates an event, and this event is attached to the event star. So this is a write operation for both databases and for the event star. And the event star here is it acts in the middle of the service B and service A, where the service B now can take a look on the event star and see all the information that it has, and then update their database with this subset of information. So yeah, the use cases for that is that you have a great compliancy for auditing trails. So that's great for financial transactions for companies that need to deal with financial operations. It's also great for healthcare records where you want to pick a point in the time, you want to look in the past and see what changed from the record of one patient, for example. It's also great for security flaws where you can go back in time, recover the state of your application, and see how something was happening, how someone could find a flaw on your security. So that's what is used. For the software engineers that are still not aware of what is event sourcing is, it is also great for versioning control with Git. So Git is a great example of synchronous event sourcing. We have our control plane with Git, and every operation that we do, be a branch naming, we can create branches, we can create releases, we can go back in time and see how our application state was. So Git was very good, is a very good example of versioning control with event sourcing. You also have the possibility of having temporal queries and analytics back in the time. So this is great for to analyze trends in your data. It's great for to see and find patterns of user behaviors in the time. And also you can do branching on the same way that we did for version control. You can also just pinpoint and imagine different paths that your analytics could go, that your data could go. And finally, not only it is good for all of these parts, it's also great for data replication and synchronization, since event stores contain all the events, everything that happens on your application, on your solution. It also acts as the source of truth for that. So now systems can have databases, and they can populate these databases of them as a view of this existing state. So they can get like a subset information part of the source of truth and can have their own interpretation of this data. And also, event sourcing is the foundational principle of something that was very famous, very hyped, which is the blockchain pattern, in which every transaction was recorded as an immutable event on a chain of blocks of transactions. So event source is also used for that. All right. So the advantages of having event sourcing is that first it is very resilient and scaled. Since now have a single place for you have a single place as a source of truth. You can now scale your applications, your databases at any time you want. You scale down. You can remove them and then go back to them in a point of time and then react the system. You have resilience, you have fault tolerances. Whoops, give you a slide away. You have a resilience on what you're showing, on what your systems are understanding. Data can be reconstructed independently, and they have fault isolation for when something bad happens. We also have the replay and reshape strategy. So it's very good for root cause analysis of issues or traces. So you have a traceability of entire workflows, very easy. You can just replay it, and you can go back in time and replay it. You can do branching. You can pinpoint an exact source of issue and see how it goes, why it happened, and streamline this troubleshooting process. And finally, we also have the interoperability. Yeah, software engineer, it's hard to name things. One of our biggest jobs, where it basically states how data should not be touched by human. A very rough explanation of it is that you don't want to have people doing manual operations on your data. You don't want to have that. You want your data to be clean through all the states, and yeah, in its raw state, it's very good for event sourcing because now you have a single source of truth which contains all of this data, and people don't have to touch it. It's a very automatic way. It's there in its raw state, and you can do operations on top of it. All right. And the challenges of this approach is that, of course, it is a very unfamiliar type of model. So a lot of people uses event sourcing, but not all of them understand very deeply how it works. It's a very niched type of pattern where you usually see more in the financial side or in the healthcares, where you have this immutability of the events that happens on the past. You also have some complexities when dealing with external systems. So we saw here that we could go back in time and see how our applications and our systems work it back in time on a specific point of time. But you would also need to have better strategies to deal with external systems that doesn't have this possibility. So in this case, you could, for example, store logs of responses that happens on the time. And as you can see here, this starts to get a bit deep and yeah, deep and big. And finally, we have also the storage resources. Since we are storing every event that happens on our application, these events are always stored, so you have to always have a good storage for that. Very good pattern to append this information so it can be fetched from anywhere else. Yeah, and this is one of the problems that it also brings, the complexity with the storage resources. All right, and now finally, let's just sum up everything that we just saw, these patterns, the key points, the benefits and bad things, and let's think of how can EDA go wrong with all of that. So the main point where you can fail when using event-driven architecture is when you don't actually need it. So it's like everything software engineer, it depends. So if you're dealing, for example, with small architectures, small applications that don't necessarily need scaling things, it's a very small business. There's not too much people in it. You don't know exactly where the business is looking at, where we are going. So if there are a few uncertainties on what is happening, what needs to be done, usually you should not go with the event-driven architecture. It adds a lot of complexity, not only operational, but it also adds to the infrastructure, to troubleshooting, to understanding your own business itself. It's a very related thing to microservices downsides, the trade-offs that you have there. And not everyone has a Netflix or or a Uber to drive, pun intended. So sometimes you just don't need to go with EDA. You can just do a small application, communicate via API. That's fine. That's fine. This works. Not only that, but we also have seen this kind of state where we can use event stores as databases themselves. Because if now you have a source of truth for everything that happens on your application, why would you need a database for that? So usually this pattern is usually people that thinks this way. Usually they have a big database, a central database, which acts like a source of truth for things. But sometimes these big databases, they are not a problem itself. They do their job. They do the job fine. Sometimes they are fine to be there, and well, some of the times you don't need to add more complexity to it, adding a second storage of it with events. So database-centric applications are fine. They're not going away because of VDA for event sourcing, for event stores. They're great as source of truth, but they are not as great as databases, specifically databases that needs to have more filtering or more logic attached to it. So what changes in EDA with the comparison that we have for databases in EDA is that the event source is the truth, is a source of truth, and the databases are a subset view of the source of truth, of the data that is inside there, the materialized concept they have. And finally, we also have that strong consistency. When you need to have a strong consistency across your systems, you need a database to know what happens on the other. At the same time, you cannot deal with the eventual consistency that comes with event-driven. Since they are in the coupled environment, it's very common to see these event consistencies happening, these eventual consistencies. And usually strong consistencies are easier to debug and see what's happening than eventual consistencies. So systems that needs that, they usually are not very fitable with event-driven. And finally, we also, very similar to this topic, we also have the synchronous communication. When all of our operations need to be more procedural, they need to have steps being done here and then the next one also be done. Usually in the systems where we need this request reply pattern, usually EDA is not a very good for that. Usually EDA is more feasible for asynchronous communication where you can decouple things and can have infinite scaling with them. All right, so now let's start with our hands-on time. We have some minutes to do that. So what we are gonna do today, we are gonna create a very simple feedback system. Since we don't have too much time and this kind of a complex architecture, we are just gonna do these first two parts here. We are gonna create an API that is gonna receive a feedback from users, and we are gonna publish an event to the PubSub tool from Google Cloud. I'm going to show it later, which is going to be delivered later. It is going to be delivered by another service, serverless function, which is going to store all of the feedbacks that we have here as events in the event store in a blob storage. So let's start with it. Since with this project can have it depends on a few setups, I'm going to use the Google Cloud shell to enable that. So first of all, I'm going to create a new project in here. I'm going to call it Tech Week EC, maybe. Okay, that is a unique name. I'm going to copy this project ID, and we're going to create this project. So it's going to take a while. And of course, I already tried this before. So I created this repository, which has these two branches. One is the finalized state of the applications. It also includes this part of the cloud function with the store event part, with the event store, the connection, and we have this main, which is the boilerplate part. So I'm gonna just to save some time on this hands-on session, I'm gonna just get this boilerplate code. So right here, oh, I believe it's got the wrong project, Tech Week AC. Let's go to this one. I'm gonna open the Cloud Shell again so it can pick up my project. Okay, so we're gonna first clone the project from Git. So we're gonna get Git clone, we're gonna copy this branch, and I'm just gonna call it hands-on. That's fine. Okay, and now in hands-on, I'm gonna enter on the folder and I'm gonna open this editor right here. And this is gonna bring me a view of a Visual Studio Code, VS Code representation of it. So we can see the folders that this repository has. So let's wait for it to open. All right, we can open here. We can select open folder and select I believe they call it hands-on, right? Yeah, I believe so. So let's open this hands-on. And this folder, we're gonna see all the dependencies that it has. There you go. So here in this package.json is where we configure our project for people that are not used to Node.js. And here we have some dependencies for creating a very simple system. These are for creating an HTTP web server. And if we open src index.js, we can see this server being configured. So as you can see here, we are initializing our project with this express, and then we are exporting a static file in this public folder, which is just an HTML. We are going to see this HTML very soon, which basically has a form to receive feedbacks from people, their name and their feedback, and then send a post request to this endpoint of our API. So right here, let's open our terminal again. We are going to first install our dependencies with yarn install. And from the scripts that we have available to run, we are gonna start with this yarn dev. So this is gonna create our web or HTTP server. Okay, so it's running. And right here in the Cloud Shell, we can have a web preview of this. So we can open this on this port 8080. And right here is the form, the HTML that we just saw. And of course, if I try to put a feedback here, it's gonna fail because we don't have any logic attached to it. Okay, so let's go back and fill it up this information. So right here, we are gonna write a post method for the feedbacks, if I'm not mistaken. Endpoint, we're gonna have the requisition and the response for it. We are gonna grab the message that comes, if we open the index.html, we can see that it gets the feedback text input and it attaches to this JSON, feedbacks and name. So let me just bring it to the side. So we are gonna get this feedback directly from the requisition body. So we have this feedback component message, and then we are gonna deal with it as a string. We're gonna do the same thing for the name of the user, and we're also gonna log something here to let us know that we received something. Let's receive it, and here the requisition body. Okay, and now that we have returned that, we are gonna also send out a 201 saying that the item was created, and we are gonna return a JSON saying, okay, true, something here, and we are gonna just return it. So this application is already done, and now it already run again. So now if we send our feedback, it's gonna be successfully submitted, and right here we'll be able to receive the request. So okay, now we did this first part of the integration, but now we want to increment that a bit to publish an event to another service. In this case, in our architecture, this API is responsible to publish to a pub sub topic. So to do with the pub sub, we're going to install one dependency. I'm going to cancel that. And we're going to install the Google Cloud pub sub dependency. Let's wait for it to finish. And right here in the code, I'm going to increment that a bit. I'm going to create a new file, call it publish.js. And this file, I'm going to import the require. I'm going to import the pub sub instance of it. We're going to initialize it, new pub sub. And we are going to create an asynchronous function to publish our message to a specific topic with a specific date inside of it. We are also going to export it. So publish message right here. And now right here in the code, in the API, we are going to put it inside a try catch to catch all the errors. So error. So we can receive all these errors and also return a 500 when something fails. So an okay false and error equals error message. And right here inside the try, we can just call it the function as in the topic that we want to listen to. So in this one, I'm gonna leave it as feedback created. And the data that we're gonna send is the direct body feedback that we have above. Actually, we can just send it as message and name as well. So that's fine. And finally, we're going to return a 201 JSON, okay, true. So this way we can remove this from below. All right, so this is already functioning. So let's increment this publish message right here. First of all, we need to stringify our JSON. So this way we can transform it as a buffer. So here from this string, we can have our buffer. And we also need to ensure our topic, this topic that we are passing, it is created in PubSub. So I'm also going to check that with this get method. And I'm going to leave this flag auto create true so we can guarantee that it's working. So here we have our PubSub topic reference. And from this PubSub topic, we can publish it. We can publish our message that we just had it buffer, publish, and this data buffer. And finally, we just completed message successfully sent. And here we can just let topic name and the data. Okay, so if we try this code, it's fine. The code part is done. If we try to run this code, we're gonna see something interesting. Start. Okay, I'm gonna try submitting here another feedback. As you can see, it's gonna take a while. Oops, authorize. Let's wait for it. Okay, so there you go. It failed to send. And when we see the why it failed, it's saying that the permission was denied. And that's because we are trying to access a Google Cloud service from a local, a local environment. So it blocks this. So we can pass that and see our API working. I'm gonna run a few comments here. So first of all, we are gonna run an emulator for PubSub. So this is gonna run internally on my local host. So I'm gonna grab my project ID right here. Oops. Again, gcloud beta emulators PubSub start project tech PC. Right. So this is gonna start this emulator for me. And on another thing right here, I'm gonna run a command to get the environment variables for that. Oh, it failed. Okay, that's fine. We can also we can just export the variable that this was gonna export for me. But this way I can just export it with this emulator host. So now I can run operations like gcloud, beta, PubSub, topics, list. And this way I can see that there is no topics for this application specifically. So now let's run our application on another terminal. So let me see here. We were in the hands-on. So I'm gonna do a yarn dev right here. Okay. And now that we have our PubSub working and our API also working, now the feedback should be successfully emitted. Oops, it wasn't. Has not been using this project or it's been enabled. Okay, let's enable it. Time, what it was normally, but doesn't seem to be the case. Okay. Let me try running this export for this other terminal as well. Okay. And now let's try again. All right, there you go. The feedback was successfully emitted and the publishing happened. So now, so we can see this happening. So we can see this emulator working and the topic that were created. We should be able to run topic list. This didn't work. Well, we can also reach out, since the CLI is not working as intended, we can also reach the API of these topics. So we can grab it here. We can create a subscriber to this topic. So let's create a subscriber. I have here the script for that. Don't worry about it. I'm gonna share it later. And we are just gonna change here the project that we are running. In this case, it is the Tech Week AC. And right below, this is also Tech Week AC. All right, we are gonna create this test subscriber, which is gonna be attached to this feedback created. So if you remember correctly, in our API, we are publishing to this topic, feedback created, and now this should create a subscriber to it. There you go, it created for this topic. And now after we publish a message, let's publish another one. Let's submit it. Okay, the feedback was successfully emitted. And now we can pull the messages from the subscriber to see if it worked. So I'm gonna do the same thing that I did for the other Tech Week AC. And there you go. We have our first message, which is in stringify in a buffer manner, but it was just published a few seconds ago. And of course, for the next parts, we would have our cloud functions working and receiving, consuming this topic, and then sending the events to the event star. But of course, I wouldn't leave it just this way because otherwise this hands-on session would be kind of boring. So I have submitted this application before in another project, and I'm going to share the link to you. And what we are going to see, I'm going to share this link very soon to you so you can publish a few messages. We are going to see our event store right here being consumed. We are going to see it being attached with your feedback. So I'm going to share this link with you in the presentation, and I'm going to please ask you to access this link and send me a feedback. So you all can share your own feedback for that. It can be literally anything. Please don't try to do a DDoS attack on that or anything else, please, as ask you. And on another hand, on another link, we also have the event store that is in your consumer. So I can open that and show you. We have here our cloud storage, which holds the blob of this information. And as you can see here, we have this event store bucket with the event start JSON file. So this file is public. And as soon as you send submission feedbacks for it, we are going to see it changing. So for example, let's give one. That's 1, 2, 3. Feedback successfully emitted. And this is cached. Let me try open it in the link again. Okay, Guilherme, test, blah, blah, blah. Guilherme Vieira, all right, should be emitting the event correctly. Let's try again. Feedback successfully emitted, and now the event store should be updated. Oh, anyway, I don't think we'll have time to debug that, but anyway, I can also see the logs being emitted to the cloud function that I created here. This is store feedback, which holds all the logs for that. I believe it's, I don't know what happened. Yeah, it was able to update it. It updated correctly. As you can see here, we are receiving the feedback. And yeah, and then this should be updated. I think it's probably because, oh, there you go. So here we go, another test. This was emitted, test online, the other one that we tried. And I don't think people are able to access the link. I don't know. Anyway, you guys can try accessing it and let me know. And you can also just, open this other link with the event store. It's a public link, and you can see how it changes accordingly to the messages that you send, the feedback that you send. All right, so this is it for our session. And well, in conclusion of all these topics, we finished it on time. And I would like to know if anyone has any questions before we end the session.
Okay, what's amazing. I love hands-on presentation. So we have a question on chat. Jimmy, do you have preference for the naming of events and what to include in it? Have read that some best practice is to avoid naming that is only CUD because it is missing the core context.
Okay, do you have press for the name of events? Thanks, Jimmy, for the question. Usually for the naming of the events, usually once you give an approach, Jamie, usually it's a common practice to follow a noun and a verb for the events in the past. So for example, we had our order placed event. This is something that already happened. It's an event in the past. So usually a common naming practice for that is to have the order as a noun of the entity that was changed and the verb of what happens to it. For example, it was created, it was finalized. It's very common to have this pattern. That is only CID because it's missing the core context. Yeah, usually you want to avoid the CUID because usually you want to have a unique identifier inside the message and not only its name. Usually for events, you want the name to be very generic and abstract so any consumers can consume it. And usually you want to change its content so it can give you the unique identifiers that you need. I hope I could answer the question. Okay, thank you.
Can I ask now? Yeah.
Sure, go ahead.
Looking towards, let me open my camera. Looking towards the future, what trends or advancements do you foresee shaping the evolution of event-driven architecture?
Well, event-driven architecture is kind of a young pattern. It has only a few years compared to other paradigms. And as we see these revolutionary AI growing, all of this state, the hype that we're seeing business taking into account, I would say that event-driven architecture is going to stay for a very long period of time. It's a robust solution for data processing, which today is really important. It's the crucial part of business that are data-driven. And event-driven is a very good architecture to handle that. It can also be, it can also be glued together with other architectures, which can only enhance more the type of processing for that. So I would say that in the data processing side, it is great. It is very strong and has huge potentials of improving the next years. And on the application sides that we have communications, it is also very effectively for dealing with scaling environments. So it attends a lot for flexibility and agility of business so they can innovate faster in this manner. So gathering data and also creating new things, creating new software solutions more fast.
Mhm. And what are some key performance metrics that we could use to track or when evaluating the effectiveness of the event-driven architecture?
Well, usually the key points that you would like to see, not only on the technical side, is to gather, first of all, the key points that we can add to it. You can have these key points. You can, of course, define your own metrics so you can understand better your users and their behaviors. It's one type of these applications. Usually in event-driven architecture, you want to have this pattern to gather these metrics from everywhere or from external systems, internal systems. And from that, you can gather all of that to have these indicators of key points. So to measure if a event-driven architecture is going well or not, usually you would like to look for the non-functional requirements of it. So if performance is doing fine, if you're understanding your business, if not only your engineers, but also business people are understanding the path that you are following, and you understand where each part completes which part. So that these are very important metrics to take into account to measure if it's working fine or not.